Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to be taking a look at something that is not quite a moon of the Earth. Speaking of the moon, here we are on the 14th of July, and the moon, the new moon, is almost right in front of the sun, as the new moon is. Of course, you wouldn't really be able to see this with the naked eye, never look directly at the sun. But the new moon is there. It is the new moon. It's more or less directly in front of the sun. Of course, it's not directly in front of the sun. It's not causing an eclipse. However, the next new moon after this one, on the 12th of August, will cause a solar eclipse. The eclipse coming up on the 12th of August, we are just entering the lunar cycle that will lead up to that eclipse on the next new moon. But we're not looking at the moon for this video. Instead, we're going to look for something that's called a quasi-satellite. A quasi-satellite is something that is interacting with the Earth's gravity. It's usually orbiting the sun at the same distance as the Earth and being at least manipulated or influenced by our gravity. You may remember from a previous video the asteroid Krine, or Creenie, as some people pronounce it. Krine, it would be the Irish pronunciation. It does come from the name of a Celtic tribe. That is a quasi-satellite of the Earth. But we are going to be looking for a different quasi-satellite. Kamo'oalewa is this asteroid, or Kamo'oalewa, depending on how you want to pronounce it. It's just gone under the horizon there. So there it is. It's not up at night time at the moment. But we can see here it is an asteroid. It's magnitude 24.5. Absolute magnitude 24.2. So it's definitely quite a faint object. We'll bring it above the horizon and we will get rid of the atmosphere, just so we have a better idea of where it is. If we take a closer look, we're not going to see very much. So this is an asteroid that was discovered fairly recently. As you can see here, 2016 is when this asteroid was discovered, so it is fairly new. But the way that it moves around the Earth, as it turns out, it's been there for centuries and will likely stay there for centuries to come. So this is a stable quasi-satellite. It's not orbiting us directly in the same way that the moon is. This little asteroid is moving in such a way as that it does seem to go around the Earth, but really it's orbiting the sun and moving around the Earth almost incidentally, just because it happens to be going around the sun in nearly the same place as the Earth. So if we take a look over here, we've got our distances. It's just about 1 AU from the sun, and it's only 0.1, almost 0.2 AU from the Earth. So it's fairly close to us. We'll get rid of the ground just so we can follow it without worrying about it going under the horizon or getting blocked out. We can see that it gets a little further from us, up to about 2.2 AU, and it gets down to just about 0.1 AU from us. So we can see here that it's staying fairly close to the Earth. Its distance from the Earth never goes. We can see here it's just getting up to 0.3 AU away there and then dropping back down. So it never gets particularly far from the Earth. It never gets too close either. We can see here even 0.1 AU, 15 million kilometers. 15 million kilometers is still pretty far away. We can see that it does go between us and the sun. So we can see its distance to the sun is going down to under an AU around here. It's just 0.899 AU away from the sun. So that more or less means that it is 0.128 AU closer to the sun than we are. Its distance from us is the distance it is closer to the sun. So this is pretty much when it's directly between us and the sun. We'll keep moving forward. We'll get back to the opposite condition. We'll get up to its furthest distance from the sun, which is just 1.1 AU, yeah, just 1.105 AU by the looks of it. So that's 165 million kilometers, and we can see that it's 0.205 AU away from us. So it's not exactly 0.205 further from the sun than we are. So this means that it's not exactly at opposition when it's here. We can see its mean opposition magnitude there is 9.65. So let's see if we can get it into opposition and get that magnitude down to something a little bit lower. It doesn't seem to go particularly low. And of course, with magnitude, low numbers means brighter. We can see it getting down to 22nd magnitude there, which is still way too faint for us to see with the naked eye. So as we can see, we've moved through a couple of years now. It is staying with us as we move around the sun. It never gets too far away from us. We're going to head out to the Solar System Observer, and we're going to take a look at the behavior of this object, how it orbits. Now, hopefully we will be able to see it fairly close to the Earth, but following objects from the perspective of the Solar System Observer is a little bit tricky. If you've watched this channel before, then you know that it is a little bit difficult to follow these objects. One thing that we're seeing here, which is important, is that the elements for epoch 2016 are being used. The orbital elements, the orbital calculations for 2016 are being used, which is probably outdated. And that's because this was discovered in 2016, so that's presumably where the original calculations come from. They have been updated, but they haven't been updated by Stellarium. We're going to bring up the orbits of objects in the solar system just to see. That is a little bit crowded, but we can see with orbits turned on for the selected object, we're not getting an orbit for this asteroid. If I turn on the orbits for everything, we can see there are a lot of orbits out there, but it's still not showing the orbit for this asteroid. However, we're going to move through time. It is close enough to the Earth that we can see the Earth as we move through time. So we can see that this object kind of looks like it's orbiting the Earth. It's trailing behind the Earth, catching up to the Earth, moving ahead of the Earth, and then falling behind the Earth. So it does almost look like an orbit. But what's really happening here is that this asteroid is orbiting the sun, and it happens to be so close to the Earth that the Earth's gravity, if we take it from the end here, so here the object is trailing the Earth, and we can see that it is here, it is further from the sun than the Earth, but as we come closer, it ends up closer to the sun than the Earth. So here, this asteroid is closer to the sun than the Earth. That means it's going to orbit the sun faster. The same way Venus and Mercury orbit the sun faster than the Earth, this asteroid is now orbiting the sun faster than the Earth. As it comes past the Earth, there's a little bit of an energy exchange. The Earth's gravity affects this asteroid. The asteroid is moved, influenced by the Earth, but this causes it to slow down and move to an outer orbit. It is now further from the sun than the Earth is. So of course it's going to orbit the sun slower, just like Mars. That causes it to fall back. It ends up further from the sun than the Earth. It's still getting a little influence from the Earth's gravity. There's still a little bit of a tug going on. But more importantly, it falls back down to a lower orbit, closer to the sun. This lets it speed up, and there it goes again, speeding past the Earth. So this is why it's a quasi-satellite. It is near the Earth. It's been near the Earth for centuries. It's going to keep doing this thing where it passes by the Earth to and fro for centuries to come. But it is only a quasi-satellite. It could easily get disturbed. Something could happen that throws it out of position. It is currently orbiting the Earth and has done for a while and will do for a while, but it's not quite the same as our moon. Speaking again of our moon, we'll come back to the Earth and we'll keep pushing back to closer to the current date, back into 2026. We'll get the atmosphere and the ground turned off again so that we can keep an eye on this object. And as I mentioned, when we take a closer look at this object, we're not really seeing anything. And that's because it is a very small asteroid. It is just a little fragment, and that's pretty much what the name of the asteroid means. Kamo'o is a fragment or a piece, and Lewa is oscillating or moving around, that is moving where it is. So Lewa, or Lewa, is oscillating to kind of move back and forth, and this does oscillate. It oscillates around the Earth, so that is a fairly accurate way to describe it. It is a fragment that oscillates, and one of the reasons it's called a fragment, or there is a chance it's just called a fragment because it's a little bit of rock, and it's a coincidence that it has been theorized that it's an ejection fragment of the moon. I don't think it's a coincidence. It is an ejection fragment of the moon, or we think it's an ejection fragment of the moon. We don't know for sure yet. However, there is a spacecraft, Tianwen-2, on its way to this asteroid. We now have better images of this asteroid thanks to the spacecraft that is now quite near to it, and hopefully we will find out soon if this asteroid is actually a piece of the moon that broke off, and maybe that's why it is so close to the Earth. Maybe that's how it entered into this quasi-satellite orbit, because it came off of something that's already in orbit around the Earth. Now, of course, that's not always the way with quasi-satellites. I do have a past video on Crini, or Krina, or Crini, whichever way you want to pronounce it, another quasi-satellite of the Earth. But this is one quasi-satellite of the Earth that is in the news recently because there is a spacecraft very near it and we're getting to know more about this object. So I hope you enjoyed getting to know more about it here. If you did, then please like this video. If you enjoy this kind of content, then please subscribe to this YouTube channel. And if you would like to read this information, you can do so on my website, queevinscontent.ie. Thank you very much for watching, and hopefully I'll see you back here next time.